Math 1, Practice 2.10.1, Interpreting Parameters. So as we have been doing, when we're talking about parameters, we're basically talking about the pieces of the function, which usually deal with where do we start, also known as our y-intercept, and how it's growing. Okay, that rate of change, or what we're adding, okay, or what we're multiplying. Alright, so looking at these functions, okay, we should identify the difference between the linear and the exponential first. So if we look at this, we should know that recognize number 1 is exponential, number 2, because of the power, and I said number 1 exponential, I meant linear, because it's 7 times x, that means repeated addition, whereas 2 to the x means repeated multiplication. So 3 is linear, 4 is exponential, and 5 is exponential. So 2 linear, 3 exponential. So with the linear, remember, we have our slope-intercept form. F of x equals mx plus b. So that's our slope, that's the number we're adding every time, that's our rate of change, and that's our start number, that's our y-intercept. So the parameters for number 1, y-intercept is 5, so it's 0, 5. And the slope is 7, so it's growing by adding 7. Okay? Our slope is 7, and you could say 7 over 1 if you wanted to. But every time x moves up 7, or x moves right 1, y moves up 7. Okay, our exponential. Now this plus 3 back here, remember that shifts the whole graph up. You know, if we're thinking about it, it normally looks like this. That plus 3, and we have an asymptote at 0, that plus 3 shifts this up to 3, which shifts your whole graph up to 3. So its y-intercept is now 4 because of this adding 3 here. Okay, so that plus 3 means our asymptote is y equals 3, our y-intercept, because that asymptote is important and a parameter to the exponential. That y-intercept is then 0, 4, because you take the starting number in front, 1, plus the 3 back there, and that gives you 4. Then this 2 is often called a base in exponentials, but that means that's what we're multiplying by, right? That's our growth is timesing by 2. Okay? Alright, now number 3, y-intercept of plus 10, so 0, 10. Our slope of negative 2, or negative 2 over 1, which means the y value goes down 2 for every time the x value goes to the right 1. Okay, now 4, there's no plus, so we just have this 2, so our y-intercept is 0, 2. Because there's no plus or minus here, our asymptote is the line y equals 0, the x-axis, and then our growth is times by 3. Remember, if we wanted the rate of change for an exponential, we would need to provide an interval to be able to do that. Okay, now last one. So normally our y-intercept would be at 0, 3, but because of this plus 5, it moved it up plus 5, right? So then this is 3 above that, so 3 and 5 give us a y-intercept of 8. And then our asymptote is at y equals 5, and our growth is we're timesing by 2, doubling. Okay, so that's just some basic parameters. Now, on the rest of them, we're actually going to look at the parameters and talk about what they mean. Alright, so number 6, you join a gym. The monthly membership fee is $10 and the rate per hour is 2. What is the function that represents this? So remember, for linear, we have to find that start. Where did we start? Well, we start every month at $10. How does it grow? Well, the rate per hour is $2. So I'd go f of x equals my starting number 10 plus $2, and 2 is the growth, so times by x, because we're adding $2 each time. So the parameters, my y-intercept, would be that membership fee, so it would be 0, 10. Every month, no matter how many times I go, have to pay that fee. And then my slope would be 2, which means that $2 per hour. Okay, so every hour I go, I'm paying $2 extra. Now, 7, Claire subscribes to a movie rental program. She pays a monthly fee of $5 plus $1.25 for each movie rented. Okay, so same idea, right? If we made a function, monthly fee is 5 plus $1.25, x being how many movies she rented. So once again, our slope is at $1.25, okay, which means for every movie she pays $1.25, and then our y-intercept would be where she starts each month, which is the monthly fee. So you'd graph per month, not like, you wouldn't make a graph with a bunch of months, you'd make a graph for each month and show how much she would spend. Okay, number 8, Max is picking apples with his brother. The number of apples in his bag is described by f of x equals 18x plus 15, where x is the number of minutes Max spends picking apples. What do the numbers 18 and 15 tell you about Max's apple picking? Okay, so 15 would be our y-intercept, right? Our starting. So what would that mean? It would mean that's how many apples they started out with. Okay? At some point they decided, well, let's see how long we're doing this, but when they looked in their basket they would have already had 15 apples. Okay? Now this 18x, x stands for the number of minutes he's picking apples. Okay? So 18 would be, since we're dealing with apples, 18 would be the slope, which means every minute he's picking 18 apples. So every minute he gets 18 more apples. Alright? That's all they want us to do on that one. Number 9, you have an ant farm. Yay, we're cool. The number of ants in your colony is described by f of x equals 10 times 2 to the x over 36, where x is in hours. What do the numbers 10 and 2 tell you about the number of ants in your colony? Well, 10, that's our starting number, remember, in exponential, a times b to the x. That's our start, or our y-intercept. That's what we're multiplying by. So our y-intercept is 0, 10. That's how many ants we start with when we first buy it. Okay? That 2, that's our growth, so we're timesing by 2, which means they double. Okay, now how fast do they double? Well, when you have a fraction up here, okay, x is dealing with hours, so 36, okay, that 36 right there means that they're doubling every 36 hours. If it was just x, it would mean they would double every hour. Alright? Now the last one. Anastasia hides $200 in her mattress and deposits $150 into an account that doubles every 10 years. What is the function that represents this scenario? What are the parameters? Okay, so this one's kind of a little weird. But the idea I'm thinking here, okay, it doubles every 10 years. That's this part of the exponential. Okay, doubles, remember, times 2, so our growth is timesing by 2, which means it doubles every 10 years, so I'd go f of x equals some number times 2 to the x over 10, because it's doubling every 10 years, just like 36. Okay, and that's our growth. Doubles times by 2 every 10 years. Okay, now she deposits 150 in, so that's her starting. That's our, we want to call that our y-intercept, but it's not quite because of that other amount. So she starts with 150 in the bank account. But what about this extra 200? Okay, well, how much total money does she have? Well, she hid 200, so we have to add 200 into her mattress. Okay, that 200 won't change, the 150 will grow. So this represents the asymptote, right? Which is another parameter here. So y equals 200. Which means that your y-intercept, 150 is what she starts with in the bank, but her y-intercept of what she totally starts with would be 150 plus 200. So it would be 350. So 0, 350 would be her y-intercept. So she starts with $350, but only the 150 goes to grow. Alright? Alright guys, there we go.